Recording in progress.
In last class, we have discussed about the CFT, crystal field theory, in which we have discussed about the octahedral, tetrahedral, and square planar complexes, how these complexes will split with the uh, with point charge. That's why the concept come, that is the CFSE, crystal field stabilization energy. Crystal field stabilization energy, if we take an example of an any octahedral complex like a titanium water 6 complex having an charge is plus 3 in the form of an 3D 1 3D1 argon 3D1 4s0 argon 3D1 4s0. In this case, if we count, there are only one electron that is here, that can split it into a two category. First is T2Z, second is EZ. In this case, DXY, DYZ, DXZ. But in case of EZ, there are a two level, DX square minus Y square and DZ square. That's why the first electron come here. After that, it absorbs some energy in the form of an light or any thermal energy, that electron will shift here, this way will shift here, and energy is known as this process is known as DD transition, and DD transition means that D electron is transferred here. This electron is transferred here. This process is known as DD transition, in which a ground state that can go to excited state. In ground state, there are some energy, like if we say E1, after that it is going in excited state, that has some energy E2. And that E2 minus E1, that is the del O, octahedral energy. This is the octahedral energy, and this absorb energy at a particular wavelength. That wavelength, that can be, we can say 520 nanometer or 243 nanometer, like this way. If it absorbs some light, means that can absorb some light which has some wavelength. Wavelength means E is equal to hc by lambda. hc by lambda. And that's why we can calculate the energy easily. And the unit of it, that del O, that octahedral energy, that is equal to 243 kilojoule per mole. That can be calculated from here, because it absorbs the energy at 520 nanometer wavelength. At 520 nanometer, we can put here the lambda value. We can easily calculate the energy. This energy come is 243 kilojoule per mole, because it absorbs the light that is has a particular wavelength, that is 520 nanometer, and every light has a tendency to absorb its color, and the color that is showing an different color, which can be shown by a Vibgyor, vi Vibgyor. Every color has some wavelength, and that wavelength can be absorbed. That's why the transition metal complex showing an Vibgyor. Violet, blue, green, yellow, or red. This way. That's why that complex showing an red color. After that, the next concept come, that is the octahedral energy. This is octahedral energy. But the overall energy of the process, that is known as CFSC. CFSC, how we calculate the CFSC? CFSC, this is the very center. Sorry, 1 second. if we count, this is in very center. This is very center. Here is 0.4 minus 0.4. 0.4 del O. And this is 0.6. 0.6 del O. If one electron is there, the total CFSE formula we can write CFSE is equal to CFSE, crystal field splitting energy, that is equal to the total number of n, we can say n number of an electron that is filling in T2G level. T2G level which has an energy minus 0.4 plus n number of electron in EG level that has an energy is 0.6, and the total of this we can write is into del O. This is octahedral. The total energy formula is expressed in form of an CFSE, crystal field splitting energy. We can say 10 into n number of electron in T2G level and n number of electron in EG level into 0.6. That is total CFSE into del O, total number of octahedral energy level. And how these CFSE can affect the d orbital, and if we take an count of another, like which factor that can affect the CFSE, कौन से फैक्टर हैं जिससे CFSE का इफेक्ट पड़ता है. तो इसके केस में CFSE क्या हो जाएगा, -0.4, 1 इलेक्ट्रॉन इज देयर इनटू डेल ओ. डेल ओ की वैल्यू क्या थी, 243. that is total energy is 97 kilojoule per mole, that adsorbed by the titanium water complex. And if number of electron we can say is 2, then number of electron is 2, then 2 into 0.4 into del O, that is minus 0.8 del O, which has more energy. This has more energy because it has 2 electron, and that is stabilized or more stability. That's why in case of if we count an D3 complex, 3 into minus 0.4 minus का 1.2 del O, 3 into minus 0.4 del O. In case of a D3 means total 3 electron. In this case, if we count in titanium, vanadium, chromium, in case of a vanadium, this is in case of a chromium. That's why there are which factor that can affect the CFSE. First term is nature of a ligand. Which type of a ligand is attached? In case of an there are a different type of a ligand that has some series, spectrochemical series. This is spectrochemical series. The ligand are attached according to spectrochemical series. Means there are some tendency, there are some stability or power of the ligand. Which ligand is strong, which ligand is weak. अगर हम बात करते हैं सीओ के केस में, तो सीओ के केस में स्ट्रॉन्ग लिगेंड क्यों हो वो, क्योंकि वो बाइंडिंग मेटल के साथ में अच्छे से कर पाता है. अच्छे से कर पाता है तो मतलब वो स्ट्रॉन्ग लिगेंड है. इन केस ऑफ ए सीएन, इफ वी काउंट सीएन, उसका पावर थोड़ा सा कम होता है एज कंपेयर टू सीओ. आफ्टर दैट NO2 which has slightly less power as compared to CN minus. After that orthophenolphthalein and pyridine, ethylene diamine, ammonia or pyridine, which has some equality power. After that, EDTA, ethylene diamine tetraacetic acid, then water, oxalate, ethanol, OH minus, F minus, NO3, Cl minus, sulfur, bromine, iodine. Means iodine, this is a weakest ligand. Weakest means if we apply some energy, not
Recording stopped.